Camille, I'm going to invite you back up, and we are going to have our next panel, and I will leave it up to you to introduce who that is.
Great. Thank you, Steve.
Okay, thank you.
Thank you, Nick, Saki.
The microphones.
No. I have the only working mic, so we can leave the...
Okay.
Yeah. Okay, it's my pleasure to introduce the second panel of the evening. So we have Dr. Alexander Kot, who's the Chief Scientist of the Army Research Lab. Come on up. We have Hava Siegelman, who's a DARPA Program Manager. I know I saw Hava over there. Please come on up. And we have Colonel Kevin Seeley, who's the Acting CIO at the Defense Health Agency. Come on up. Thank you guys for joining me tonight. Okay, so we have a little bit of a silly question that we're going to kick off with. So Vladimir Putin said that the country that leads in AI will be the ruler of the world. Is he correct? We're going to start with Dr. Kot.
Where's the working mic?
There you go.
All right. So tonight is the third night of Hanukkah, so happy Hanukkah to all those who celebrate Hanukkah. I would not necessarily put too much emphasis on opinions of Vladimir Putin. AI is important. AI will be important. AI is a future. Not the future, but a future of many things to come. AI also has been around a long time. I've been doing AI, applied AI in 1980s, believe it or not. And even at that time, it was the future. So AI is the future, and it always will be.
Hava, you've also been, you can respond to that, but I know you've been doing AI for 25 years, I believe?
Yes. So it's true that the first paper on AI was written in 1948 by Alan Turing, but things have changed since then. And
a little bit.
A little bit. And I think that since 2012, we kind of consider it as the new wave of AI. And in the last year, I would say there are also a few very important changes to the field. So I actually think that Vladimir Putin said something very smart, because the future that we see AI in is an autonomous system, which means that we don't have to send people in, or dogs, or anything alive that we don't want to be hurt. We can actually send the robot to do things for us. And there is data, there is cybersecurity, there is adversarial information, there is information that you want to keep unleaked. So through smart use of computer and through AI, you can really go very, very far in government and in between countries.
Colonel Seeley?
First, let me say I'm honored and humbled to share the stage with these two individuals. But I'm having flashbacks to Sputnik, not to characterize what Vladimir Putin says, but the important piece of that, I think the answer is that we need to keep up, right? That's the important piece.
So I want to talk a little bit about AI in the defense space. We'll start with Dr. Kot. Where do you see the most frequent use of the machine-human pairing?
So, coming from the United States Army Research Laboratory, I'm looking at the future battlefield, ground battlefield. And we envision it as that future battlefield populated by teams of humans and intelligent things, things of variety of nature. And this could be the vehicles, this could be the munitions, this could be sensors, this could be wearable devices. These are physical things, and of course there are non-physical things, the decision aids, the analysis aids, the autonomous cyber defense agents and things like this. And all these things will have to work together between themselves and with the human soldiers. The human soldiers will not have time to babysit them. The ground battlefield is a very dangerous and busy place, and they have to focus on their tasks. So these intelligent things will have to have a degree of autonomy and intelligence to collaborate between themselves, collaborate with the human warfighters. We see them not as tools, but rather teammates, and that's a huge difference. They will have to become teammates. They will have to become helpers and participants in the overall battlefield mission. And that means a lot of things. It means that we will need not only to build this kind of technology and this kind of agents, and we do have a broad range of programs within the Army Research Laboratory and in collaboration with our academic partners, building the physical things which are becoming more and more intelligent, building non-physical, disembodied agents such as cyber defense, autonomy. But perhaps the most difficult challenge is how to make them to understand each other. There is a fundamental difference between how machines think and perceive and communicate and how humans perceive, think, communicate. And bridging that gap is a largely unsolved and poorly understood research problem.
And we'll get to that in a second and talk about the some of the biases and things like that and ethical questions. How about, do you want to add to that?
Yeah, I would like to add. I think Dr. Kot talked about a lot of things. So I think when we think about the warrior standing there outside and trying to do things, then there's a great capability in virtual reality. So virtual reality seems to be an amazing tool. So if you stand and there is a building, you can actually, with a good virtual reality, be able to see what's inside the building, what's inside the rooms. So with enough sensors and with a way to connect it to you so that you can actually use it in an immediate way, that you don't have to type on your computer or to ask questions, but you can actually look around and see what's there. So there are many great ways to communicate in such a natural way that you don't even notice. Or you look around and there is writing that tells you, 5 people behind you, or things of that kind.
Councilor?
I think in many ways, we're early in the fetal stages of what AI can do for, in my case, healthcare. I think Dr. Kot hit on it. It has to help, right? No matter what, it has to help. It cannot be a hindrance. And I think even with the technology that we have in a lot of environments and a lot of industries today, end users feel like technology is working against them. I think it would be ideal if AI and even big data analytics for things like clinical decision support, drug-drug interaction, adverse reactions, patient safety, all of those things that I think can be aided and helped by in the healthcare industry by AI. We have to get to that point. I mean, we're really at the point where we're still in big data analytics and the clinical decision support that we're doing. The insights that are available in the data sets that we have, they haven't been quite merged yet across the board. Now, providing that data, talk about the security just for a second, providing and opening up that data to allow that is an inherent challenge in and of itself. Getting that data opened up. I know it's U.S. Digital Services. It started that with the large data sets. FDA is doing the same with adverse vaccine reactions. But I think we're at the fetal stages of a lot of this.
And I want to drill down into more of the actual use cases. Hava, you're in charge of this really cool program called Lifelong Learning Machines Program. Can you talk a little bit about that?
Sure. So that's my topic. I would love to talk about it. So this is a relatively, actually very new program of DARPA that is just now under contracting, so it didn't even start. So we're talking about something very, very new. So a lot of the AI that was mentioned here was based on taking data and crunching it and mining it and having all the time in the world to use that. What really happened is in many applications, and not only in the DoD, in many applications we don't have that amount of data and we don't have that amount of time. And we don't have this capability to, to take data from Afghanistan and to run it in Pakistan, because things are not exactly the same. So what do? How we can take just the little bit data that we have and use it and not fail. So the idea of lifelong learning machines is to have something that we all do. We actually learn from our experience. So what does it mean? All the current AI applications and demonstrations that we have, what they do, there is a program that writes, perhaps people went to expert and ask how to do things and how to come to decisions, and there is some part there. Then there is another part that is based on machine learning in all kind of way, which is what we call parameter learning. So you have, let's say, some type of neural networks and some type of propagation or learning algorithm. But what really happened is that you have the program and the learning from the data all done before. And once it's all ready, you fix it. That's it. And then you field it. Okay, so think about the equivalence with us. You learn, you go to first grade to second grade. That's it. And now you have to continue work in the world. So this is very much not the way that we work. We actually use our experience. So when we apply our knowledge, we also take it back as a new training set. The reason that it was not done before is that it's actually very hard. It's actually very hard to reopen and continue learning, because the way that currently AI is built is that it's smart to use very, very large data, but it's frozen. If you want, with current AI, if you wanted to take a new data and put it in, it will actually erase the previous data. Because let's say you have a neural network with many parameters, it learns on 5 million examples. But when you take, let's say it was in some self-driving car and the self-driving car had an accident, so you want to take the last 150 frames and include it in the network. So if you take the last 150 examples and now put it in the network, it will write on all the parameters and will actually erase a lot of the previous information, and we will not know which. So there is actually a lot of smart and thinking of how to do this system that can learn on the go. So the system will train very little in advance. It will more kind of learn how to learn, and it will start with what it knows. It will be fielded, and once it's fielded, it will start operating. And if it sees that something is wrong, so in current AI, if something is wrong, you go to default and you do your default. Let's say all the time something is wrong because you're not prepared. Current AI will all the time give you default, will all the time do the same accident. In lifelong learning, it will fail first. It will realize that it's not doing well, and it will be able to tune and open and decide what from the word it takes to be its training set, its new training set, how to do it and cooperate it in. So this is really a very, very new way of AI, and we kind of think that this will really help in many, many ways, from actually big data that you'll not need to have so big, because you don't really care about the data. What you care is about what to do next. Mm-hmm. And for, autonomous system, for decision support, for merging, for many, many applications.
I want to go back to something Dr. Kott said, and in my previous discussions with you, we talked about the challenge of AI on the battlefield and countering deceptive AI and bad data. How do you overcome those obstacles?
Indeed, there are some massive challenges in applying AI to extremely complex and messy world of ground warfare. One of them, of course, is what I called D5. Dinky, dirty, dynamic, deceptive data. Write this down, please. Dinky, dirty,
dirty,
dynamic, deceptive data.
data.
That's what you get. Instead of your a beautiful Googlish kind of million pictures of dogs and million pictures of cats that you can use to train your typical machine learning algorithm, you get a mess. You get data which are not nearly as numerous as you want. You may see 5 pictures of IEDs, improvised explosive devices, not a million necessarily of them. They constantly change. Nobody is going to label them. There's no time and no interest for anybody to label them. Very often there's more noise there than signal. In that sense, they're dirty. They're dynamic, they're changing all the time because the enemy is adapting and the enemy is doing new things every week. Every day, and they're deceptive because everything in the warfare is about deception. So how do you deal with those kind of data? And what Chava is doing in lifelong learning is solving some of these very difficult problems, particularly dynamically changing environment, so that a more plastic kind of mind of future AI could adapt itself continuously without forgetting important things from the past, right?
Yeah.
So this is one huge problem, D5. Do you remember what D5 stands for? There's a quiz after this. The second thing that I would like to mention is a huge problem of adversarial learning. Adversarial learning is a rapidly growing field of research in which it was discovered relatively recently that we can very consistently and reliably fool AI if it's based on conventional machine learning. And we can do it even without knowing what's inside of that particular machine learning algorithm, because it turns out that we can figure out relatively reliable deception methods even if we don't know exactly what machine learning algorithm is being used. Imagine that. You know, with much wisdom comes much,
Power, responsibility?
No, troubles. The more you learn, that's what all deception is based on. The enemy finds out what you have learned and uses that to deceive you. And of course, that's what we're seeing here. This is a whole new world. We're actively working in that field in the adversarial learning. You will probably hear more and more about it as time goes on.
It's just funny because I'm currently working on my next program, which will be called A2I for adversarial AI, which will really have to deal with the things of how to trick and how to strengthen.
Maybe you can partner up.
Brilliant people think similarly.
So, Colonel Seeley, I want to tie that back into the space you're in. How do you deal with, in the health space, dirty, dinky, dynamic, deceptive data, or tainted data? Tainted data.
So we scrub our data. We do have data scientists that work in the healthcare space and the Defense Health Agency, and we look at our data and we clean it, and we throw out the stuff that we believe might be tainted or that skews our patterns and trend recognition for our from some deep learning algorithms. So we do some of that, and it does help the things that we're doing. Where we have to be concerned, I think, where the adversary wants to do harm, right? For us, woe to the early adopter who has to live through some of the accidents. In healthcare, we really don't want to take that chance. So it has to be not the infant or the fetal stages, but the adolescent and the adult matured technology, so that we don't harm our soldiers, sailors, airmen, and Marines. That we're very proud of the survival rate in the last few wars by saving a lot of lives due to the improvements in technology, which were quite a bit partnered with innovations from DARPA and others. We were able to really improve our survival rate in the last few wars over any other war in history. So that's an important piece for us. So, and the AI, it definitely concerns me, but I'm also excited about the ability of the machine learning to real-time respond to cyber attacks and those that want to do our data harm across the healthcare space.
One of the most interesting stories I've read so far about AI has to do with some of the ethical aspects. Actually, Amanda, our reporter, wrote about something that Justin Herman said, that there are questions that you have to start considering when it comes to managing AI. So do you manage AI as a human resource asset, or do you manage that? How do you manage that? But what I wanted to talk about was more of the ethical sides of how do you make sure that AI isn't biased? So there's this algorithmic bias that exists. Hava, do you want to take a stab at that question?
Sure. So, like everything that is based on data, if the data is biased, the machine is biased. And AI is today becoming a very, very strong tool, and a tool that is not constrained by things that we are constrained, like what we can say in public and what we should not say, even if statistically there is some truth to that, because it has to change. And the machine does not have these things unless it is particularly told and trained not to do these things. So there is a responsibility when you do AI and when you want to listen to that and put it outside, for people to use. You have a responsibility to teach it what you would teach your little child. And this is something that you have to do, or else you put a huge power in the hand of a box that should not have it, because it's not sensitive.
And then you have a robot revolution and taking over the world, right?
Well, for the robots, to talk to each other and communicate to each other and define joint goals, this probably will be the next program. So
We don't have to worry
almost
about
there.
that right now, right?
Not yet.
Not yet. Dr. Kott?
I believe that machines do not have biases. We have biases. And whenever there is a situation when people say, well, algorithm has bias. No, we introduced a bias into that algorithm. So let's look in the mirror, and that's where the AI bias really resides. But you're absolutely right that there's an enormous challenge of how do we control and manage AI more generally. It's okay if you are talking about one program that resides on one processor and we have some knobs and buttons to control it in some ways. But we recently started a new large collaborative research alliance, which is kind of a collaborative program between government scientists and academia scientists, and it's called Internet of Battle Things. Internet of Battle Things. So imagine literally tens of thousands, hundreds of thousands, potentially millions of independent, intelligent things that are all working together between themselves and with the soldiers, and they're constantly being very fluid. Things change all the time because the enemy is out there trying to disrupt and destroy them, and so everything gets rewired literally every few seconds, and everything gets partially destroyed and restored, and so on and so on. How do you manage that kind of AI? That kind of AI. What do you do about that one, which is to a very large extent is emerging process. It's emerging thinking between all those hundreds of thousands of things.
Don't worry, that's next on Hava's programs to launch.
That's right. So anyways, I wanted to mention that the issues of managing this kind of complexity is probably a lot more challenging than just making sure that one particular program doesn't tweet something that is incorrect.
Colonel Seeley, do you want to add?
Well, It's just that. I mean, these are advanced difference engines that we've been working on since the 80s, and I like to watch a lot of Discovery and Science and History Channel and even C-SPAN, and you hear a lot of great things about how advanced AI has become to do the things that it does. It is quite amazing. And it is the future of the battle space, right? I mean, we understand that cyberspace and those things that come, they're for good, and the adversary will figure out how to attack them as well, ensuring they're secure and ensuring those battle bots and the things that are helping us treat folks on the battlefield they're helping us. Right, they have to help us, and we got to know they're secure. I mean, the early drones that fly and potentially have their data streams interrupted by enemies are a good example of we've learned some of those things early on with the self-driving cars and the drones and everything else, and we are again at the fetal stages. But to see where it's going to go, it leaves a lot to the imagination.
I think we can take two audience questions. Mike? Do you have a mic? Okay. So Mike will walk around with a mic. Questions for the panel? All right, first row here.
Sure.
Tell us who you are,
Hi,
what organization
I'm
you're
Phil Feldman. I'm with ASRC Federal. A lot of what we have to deal with resiliency brings to mind a lot of my training as an ecologist. And I would be curious to see how you are incorporating those ideas of ecological resiliency into machine learning and AI concepts. Because that seems to be an area where there are systems that can be nearly completely destroyed and rebuild themselves in an emergent way.
Thank you so much. You're bringing up a tremendously interesting point. I'm just about to send a book to the publisher Springer on cyber resilience, and some of the ideas there are certainly borrowed to some extent from ecological and biological analogies. So yes, there is a growing trend or thread of thinking in that direction in cyber resilience in particular. So yes, the answer is yes. Is that good?
Hi, my name is Leye, I know, BAE Systems. I have a non-trivial question, and that is it possible to build a foolproof prime directive into AI systems so that this will be one way to make people comfortable with this kind of systems, knowing full well that it can do no wrong?
Okay. Can you build a system that can do no harm?
So you're saying,
Right.
is
That
it possible to build a provably correct and harmless system?
Right.
It's very easy. Make sure it doesn't do anything. Any thoughts about that?
Do you want to add to that?
So there are actually two programs in DARPA that have to do with assured autonomy and explainable AI, which try to make people more comfortable. It is the reality that once you make a system and you try to make it more comfortable to the person to use it, the system loses some of its capability. It's the same like us. If we will do everything only if we can rationalize and explain them and will not make any other thing, it will harm our capabilities. And the same is true for a system. So there is really a balance, and it is a good balance there. In practicality, sometimes we don't want to do all the fancy things that we researchers love to invent, but sometimes we have to kind of take it low and comfortable. So it's a good point.
One last question.
Hi, I'm Dan Kunzig from Oracle, and I was wondering if you could elaborate a little more about how close we are from an explainable AI perspective to being equivalent to expert systems.
I'm not sure I understood.
the explainable AI interface you were just referencing. I was wondering how close we are to actually achieving that and being have AI actually explain its decision-making process.
So the program of explainable AI is actually interesting. So it does not only build on nodes that have meaning in advance, but it has to come up with explanation just as it come up with its behavior. So it learns at the same time what to do and how to talk about it. So it's something that has to do with natural language or with modeling at the same time that it does the thinking. So that is the kind of thinking that is done now. It's not great yet. You know, the program is still there. There was also a previous program of IARPA that didn't reach very high. And the one of DARPA has some different side that the hope is to reach higher with that.
Thank you.
I would add to that I personally slightly skeptical about the success or great success of that effort. Dave Gunning is a great guy, and he seems to have a golden touch. Every program he touches turns into some form of success. I'm not sure if it will be explainable AI. It will be something else, perhaps. But you know, if it succeeds, it actually has a promise of something much greater, perhaps some sort of a connection between sub-symbolic and symbolic AI, which is a holy grail of AI for decades and decades.
That concludes our programming. Thank you to the speakers, to the audience, those who are watching on the live stream. Please stay and have a few more cocktails. Network, make sure to ask really good questions. The panelists will be available, right? Sure. Yeah, now they have to. Thank you and happy holidays. We'll see you in late February for our next event. Thank you.